And now this question asks us to determine the reaction at the support, and we know it's equilibrium. So we have to draw the free body diagram first. So the free body diagram is here, and I kind of like divide this distributing load into the force here, the rectangle and the triangle here. So it's like this force is like this 600 and times 3 plus 3 is 6 times 6 is here is 3600, and this force is 300 times 3 and divide 2, so it's 450 here. And if the summation Fx equals 0 because it's equilibrium, and the Bx here, it only has the x force here, Bx is equal 0, and the summation Fy equals 0, and we have the By here and plus Ay here. And also this force and this force. And now we have to figure out the summation NB if that is 0, because it's also equilibrium. And summation B is 0. It means like the Bx force is 0 and By force is 0. All the force on the point B is 0. So we ignore them. We only calculate Ay times 6, and it could be also, and the distance is the centroid of the triangle here, so it's 5, and the centroid of the rectangle is, it's 3 here, centroid. So we know the Ay is this. Now we know the Ay, we can calculate the By here. So By is like this. It's the answer of this question. And this question, we have to determine the component of the support reaction at the fixed support A on this beam. So now we have to draw the free body diagram first. So the point A, it could be Ax here and Ay here and other force here. So it's equilibrium. So summation Fx equals 0. So every force in the x-axis here is this, and also this. So the force here would be like Ax, and the 4 times cosine 30, because cosine 30 is like this, 4 times cosine 30. And we know the answer Ax is 3.46 kN. And the summation Fy here, Fy equals to 0. So every force on the y-axis is this force and this force also. So it's 6 plus, and also this force, cosine 60, and it's Ay. So we know Ay is 8. And the summation MA here is equal to 0. So every force from the force here, and their distance is like 6 times 1.5 and plus 4 times cosine 6 here, cosine 60 here, and times the distance. The distance is also 1.5 times cosine 30 and plus 3, because this force here is cosine 30 and plus 3 and plus 4 cosine 30, and the distance is here, sine 30. So it's 0.5 sine 30, and the answer is this. So we know the AX, AY, and the moment A. And this force, we also draw something like the free body diagram. This force into, we have this force, this force, this force, and this force, and this force. So it's equilibrium, and the Fy equal 0, and this force FAB cosine 50, because this force is FAB cosine 50, and this force here is force AB sine 50. It's y-axis force, and this is x-axis force. So y-axis force is this, and plus cy, and also have this 6. And the summation fx equals 0, so FAB sine 50, and also cx, and here 2, so equals 0. And now we have to calculate the summation at MC, because the question says we have to determine the horizontal and vertical components of reaction at the pin C and the force at strike AB. So summation MC here is 0. So we have to know the distance here and here, and the BC here. The angle is 20 and it's 400. So we know tangent 20 is BC. So we know the BC, distance BC. So here also, it's also 20, and the tangent 21. This and this for x. Here tangent is x. So x will be 1 tangent 20. So summation MC 0 minus FAB force times sine 50, and the distance is 0.3 m, and plus FAB here, the cosine F50, and the distance is this BC, so it times 0.4 tangent 20. And you also minus 2, this 2, and the distance is here, is 600 plus 400, so it's 1 meter. So you also have to calculate this force 6, and times 1 tangent 20 is this force. So the answer is FAB is 864, and so this we can know the CX is 2.66, and the CY is 656, and the last question is the 3D dimension questions, and we have to draw it, the picture here. So it has the force AX here and force AY here, and the long mountains here, 900 here, and here. And B here also has the force BZ, and BX here, and here also has 500 here and 600 here. So we know it's the 3-dimension question, and summation fx here, and because it is equilibrium, so summation fx equals 0. So every force at the x-axis is this one, x way has ax and bx, and also this 500, and summation fy equals 0, and we have cy. So here cy, cz, cy here, and this here, and summation fz equals 0. So we have az plus bz plus cz, and is 900 plus 600, so it's 1,500. And we have to calculate and summation mx axis. So every moment at the force axis have to time their distance. So here 600 have to times minus 600. It have to time the distance 0.9, and the bz here times the distance from the bz to the x-axis 1.8, and minus 900 times 10.7, and plus cz. So you can write down like this: 3bz plus 2cz is equal 3,000 here. And the summation my here is 300 times 0.6, and plus cz times 1.8, and it's 900 times 1.6, and the y-axis at the force and the distance. So you can write down like, so we know the cz is 250, and we know the cz, we can know the bz here. So the bz is 1,125, And we know the CZ, BZ here. We can know the AZ is 125. So now we know the AZ, BZ, and CZ. And let's move on. Let's move on to the summation MX. So the summation MZ is 500 times 0.9 because here and the distance minus BX times 1.8 and plus 450 times 0.9. So we know the BX is equal, also minus CY. So we know the BX plus CY is equal to 475. And now we know CY is 450, so BX is 25. So we know the AX, AZ, and BX, BZ, and CY, and CZ. It is the answer.